Our bodies are very sensitive to hormones, and so it's important to control the amount of hormones which is present in the blood. So how does our body control that? Well, that's basically what we're going to find out in this video. So the ways of controlling the amount of hormones in our blood or regulating these hormones is done by a mechanism called the feedback mechanism. So what exactly is this? Well, to give you a broad overview, it's a mechanism by which the organs that secrete hormones, they get a message of whether the hormones are doing their job or not. And based on that message, they will decide whether to secrete more hormones or to secrete less. Now it'll make a lot of sense if I take a very specific example, right? So let's take the example of pancreas and insulin. Now we already talked about the role of pancreas in a previous video called the endocrine system, but just to give you a recap, whenever the blood sugar level rises beyond a point, your pancreas tries to reduce it. Why? Why is it important to reduce it? Well, because if you have too much blood sugar, then that sugar can actually damage the blood vessels. And as a result, blood may not reach all the cells. Oxygen may not reach all the cells could die, and that could be catastrophic. So very high blood sugar is very bad for us, very dangerous for us. And so for that, what does the pancreas do? Well, whenever pancreas detect a very high level of blood sugar, you know what it does? Immediately, it starts secreting a hormone called insulin. Insulin gets into the blood and it tells all the cells to start absorbing more blood sugar. That's what insulin does. It gives the message to the cells, and as a result, the cells start absorbing more blood sugar. What does that do? Well, because now more sugar is being absorbed from the blood sugar level starts dropping. So the blood sugar starts dropping, and now we are out of danger. So this can happen immediately after eating something very sweet like cake or chocolate. The moment that happens, the blood sugar rises, your pancreas secrete insulin, that asks the cells to absorb more blood sugar, and that reduces the blood sugar. Now this is great, but imagine if this kept on happening. If this keeps on happening, your blood sugar level will keep on dropping, and after a point it'll become very low. That's also bad. We don't want too low blood sugar, because if that also happens, then your blood will not have any sugar, and sugar is important because sugar gives you energy. And so sugar is definitely needed, and therefore if this continues, that's also a problem. So how do we make sure the blood sugar level doesn't drop too low? So this is where the feedback mechanism comes into picture. So the moment the blood sugar level drops beyond a particular point, it goes low, that message is fed back to the pancreas. I mean, think about it. The blood goes to all the organs, and so this blood is going to the pancreas as well. And so the pancreas detect that. So once the pancreas detect that the blood sugar has become low enough, the pancreas says, okay, the blood sugar level is fine. I don't need to produce more insulin. So that stops the production of insulin, or at least it reduces the production of insulin. But let's say it stops over here, just to keep it simple. So that message stops, and the cells stop absorbing more blood from the sugar. And as a result, the blood sugar level will stay same, and everything stays fine. And so you see, this is how, by using the feedback, the pancreas can control the amount of insulin to be present in the blood. This is the whole idea behind the feedback mechanism. Now, of course, if you study in more depth, we will call this as a negative feedback, because the message is making the organ reduce the amount of hormone secretion, right? There are other feedback mechanisms in which the message will make the organ increase the amount of hormone secretion. But you know what, for our case, we don't have to worry too much about this positive and negative feedback. Don't worry about that. Just understand feedback mechanism in general. So anyways, for this, let me take one more example. Let's now consider the example of the pituitary gland. You may recall, again, from our previous video on endocrine systems, that the pituitary gland is the master gland which controls the secretions of all the other endocrine glands, right? So let's see how pituitary controls the thyroid glands. So whenever you eat food, let's say, and your body needs energy, that food needs to be metabolized. So when that happens, the pituitary senses that, and it starts triggering the thyroid gland. So basically what happens over here is the pituitary gland sends a hormone to the thyroid gland, and even though the name is not important, I'm just gonna write that down. It's called the thyroid stimulating hormone. Okay, so it sends a hormone to the thyroid gland, and the name itself tells, what does the hormone do? This hormone stimulates the thyroid. Basically, it tells the thyroid, hey, thyroid, start producing thyroxine. Okay, so the thyroid gland starts secreting thyroxine into the blood, and as a result, the blood thyroxine level starts rising, and thyroxine is the one that conveys the message to the cells, start metabolizing that food. So it increases the metabolism of the food. That's one of the things thyroxine does. And as a result, your food starts getting metabolized and you start getting more energy. Great. But again, you don't want to metabolize too much. You don't want to get too much energy in your body. And so again, this amount of thyroxine in the blood should also be controlled. So how does that happen? Again, by the feedback mechanism. So once the blood thyroxine level increases beyond a point, that message is fed back to the pituitary. So the message goes back to the pituitary. Again, because blood is given to all the organs, even to the brain, pituitary is in the brain. And so the pituitary gets that message, and then it realizes, okay, there is enough thyroxine in the blood, I can reduce the amount of thyroxine, and so the blood, the pituitary stops. So let me just use this. Yeah, the pituitary stops sending the hormone to the thyroid gland, and as a result, the thyroid gland stops producing thyroxine, and as a result, the amount of thyroxine in the blood stops increasing, and now we have controlled the amount of thyroxine in the blood. So this is how, again, we can see the feedback mechanism regulates the amount of hormones present in the blood. Now, before we wind up, since we are on the subject of thyroid gland, I want to talk a little bit about iodine deficiency. This might be important for you to remember from your exam point of view. Now, at first, you may be wondering, where does iodine come from? Out of the blue. Suddenly, why am I talking about iodine? How is it important over here? Well, one thing that I didn't tell you earlier is that for the thyroid gland to make thyroxine, let me just get rid of the feedback loop for a while. So let me just get rid of that. It's okay. Now, in order for the thyroid gland to make thyroxine, it needs iodine. So every time thyroid gland gets stimulated from the pituitary gland, what thyroid gland does, it absorbs thyroxine. Let me just write that down over here. It absorbs the iodine. It absorbs the iodine. And then using that iodine, it can make thyroxine and then secrete it. Now imagine what happens if there isn't enough iodine in your body. Let's say there is no iodine in your body. What happens? Well, let's see. Again, let's work from here. The pituitary says, hey thyroid, start making thyroxine. It sends a hormone to it. The thyroid says, okay, cool, let's do that, but there is no iodine. Since there is no iodine, the thyroid gland is trying to make thyroxine, but it can't make. So there is no thyroxine. And as a result, the blood thyroxine level does not increase. That message is again fed back to the pituitary, right? Let me just again put that up. So that message is fed back to the pituitary. And the pituitary says, weird, the blood thyroxine has not increased. Okay, it starts sending another hormone and says, hey thyroid, make thyroxine. Thyroid says, okay, cool, I need iodine, but there is no iodine, so it doesn't make thyroxine. It doesn't increase the blood thyroxine level. And this keeps on continuing, and the pituitary keeps on sending stimulating hormones over and over and over again. It keeps on stimulating the thyroid gland. Now, the thyroid, you know what happens because of this? As the thyroid gland is getting an unusually large amount of hormones, the cells of the thyroid gland think, hey, we need to make a lot of thyroxine. And as a result, they start swelling. All right, as a result of that, they start swelling. Now, if you're asking me, why do they swell? Think of it this way. To produce a lot of hormone, you need a lot of space. Think of it that way. And as a result, to make that space, the thyroid cells start swelling up. These cells start swelling up, sorry. And because the thyroid gland is situated in the front of your neck, this means the front of your neck starts swelling as well. Let me show you that. Okay, a situation like this causes the front of your neck to swell. And this particular disease is called goiter. So let me just use the same color. Okay, this is called goiter. So what is goiter? It is a swelling of the neck. Why does that happen? Because of the swelling of the thyroid. Why does that happen? Because of the continuous stimulation from the pituitary. And why is that happening? Because the thyroid is not able to make thyroxine. Why is that happening? Because of iodine deficiency. So iodine deficiency ultimately causes goiter. Now the thing is, our body cannot synthesize iodine all by itself. And therefore, it's important to make iodine as a part of our diet. And it's for this reason the salt that we intake today, the salt that we use in our food, is always iodized salt. You may have heard of this in commercials. They keep talking about iodized salt. Why do we do that? Because salt is a part of most of the diet, and as a result, this will ensure that most people, regardless of what their diet is, are going to get enough intake of iodine from that salt. And that is the story of iodine. So to quickly summarize, what's feedback mechanism? Well, whenever a gland secretes a hormone into the blood, the message of whether the hormone has done its job or not is fed back to that gland, and based on that message, it can control the amount of secretion. This feedback mechanism regulates the amount of hormones which you'll find in our blood.